In this video, we're going to look at a problem called the drunkard's walk. We've got our drunkard here. He stood 1 metre away from the edge of a cliff. Now, he's so drunk that he doesn't have much control over where he's moving, but he's got a probability of 1/3 that he will take a step 1 metre to the left, which in this case would lead to him falling off the cliff. And he's got a probability of 2/3 of taking a step to the right, where he'll move 1 metre away from the cliff. If he does that, the problem starts again. So he's got a probability of 1/3 of moving back to the left again. He's got a probability of 2/3 of moving to the right. And this continues. We want to know, given these facts, what is the probability that the drunkard will eventually fall off the cliff? To solve this problem, we're going to model it as in the diagram here. So I've got a number line from 0 going upwards. Our drunkard is currently stood at 1. If he moves 1 step to the left, that's 0. That's the end of the cliff. If he moves 1 step to the right, he gets to place 2, and so on and so on. Using this, we're going to define pk as a probability of eventually falling off the cliff after starting at place k. Using this, we can see that p0, so the probability if he starts at place 0, well, he's already off the cliff there, so p0 is going to equal 1. And we can also see that as the probability of moving to the right is bigger than the probability of moving to the left, as k tends towards infinity, i.e. the starting point moves further and further away from the cliff, the probability of falling off the cliff is going to tend to 0. We can also create a formula using these. If we pick any point, k, our drunkard has got a probability of 1/3 of moving to the left to point k minus 1, where we can then restart the probability as the probability of him falling off the cliff at that place. And he's got 2/3 of moving a step to the right to place k plus 1. But again, from that point, he'll have a probability of p k plus 1 of falling off the cliff. So for any point k, we can say that pk is equal to 1/3 times p k minus 1, the left point, plus 2/3 times p k plus 1 for the right point. We're now going to start rearranging this equation we've just made. So let's multiply through by 3 to get rid of the fractions. So we get 3pk equals pk minus 1 plus 2pk plus 1. Now I'm going to subtract the pk minus 1 from both sides and subtract 2 lots of pk from both sides. So we've now got pk minus pk minus 1 is equal to 2 pk plus 1 minus 2pk. Well, let's factorise the right hand side. Bring that 2 out, so it's 2 lots of pk plus 1 minus pk. We can now see both sides are very similar. We've got a p with a higher k minus a p with a k1 lower on both sides. So let's define a new object now. We're going to say dk is the difference between pk and pk minus 1. So the probability at one point minus the probability at the point nearer the cliff. We can now replace both sides of this with d's. We can see the left hand side is dk. We can see the right hand side, that bracket, because it starts with pk plus 1, is dk plus 1. So we can say that dk is equal to 2 lots of dk plus 1. Hence dk plus 1 is equal to 1/2 dk. Now if we kept this going with dk, we can see that, so for example, dk is going to equal 1/2 dk minus 1. This would equal 1/2 of dk minus 2, so on and so on. So to get down to d1, we can take out a further k minus 1 halves. Right? So just for each dk, we're taking out 1/2 and lowering the k. So dk plus 1, by following this through to the end, must equal 1/2 to the power of k times by d1. Now we've got our formula for dk plus 1, and we know what p0 is. We're going to try and find a way to bring these together. And the way we're going to start this is we're going to take pk and we're going to rewrite it like this. Now what's happened here is, on the right hand side, I've got p0, because we know what p0 is. I then added that first bracket, which is p1 minus p0. So we can see that those p0s are going to cancel out. The second bracket is P2 minus P1. So that minus P1 will cancel out the P1 from the first bracket. And we keep on adding these brackets all the way up to PK minus 1. So we can see that by adding these brackets, the P that's being taken away will cancel out one that's been brought in earlier. The only thing that's going to be left on the right-hand side, not cancelled out, is the PK at the end. So these two are equal to each other. We haven't inserted anything, we haven't substituted anything. It's just a different way of writing PK. And the reason we've done this, as I say, we know what P0 is, and all of our brackets, we can replace them with D's. So PK is going to equal P0 plus D1 for the first bracket, D2 for the second bracket, so on, all the way up to DK. Now this is just the sum of K's, so we've got P0 plus the sum of, from n equals 1 to k, of dn. But we know that dk plus 1 is equal to a half to the power of k d1, so we can replace that dn with a half to the n minus 1 d1, and d1 is just a constant, so let's take that out. So far we've got that pk is equal to P0 plus D1 times the sum from n is 1 to k of a half to the power of n minus 1. So looking at what we've got so far, we know that P0 is 1, we've got a value for that, but we've also got a value for pk as k tends towards infinity. So let's work with that. Using our formula that we've just created, we can say that P infinity is going to equal P0 plus D1 times the sum from n equals 1 to infinity of a half to the n minus 1. Now this sum is just a half to the 0, which is 1, plus a half squared, plus a half cubed, so on and so on. Well, the total of that is going to be 2, which you can work out by using sum to infinities. So we get that P infinity is equal to P0 plus 2 lots of D1. Now let's sub in our values for our two P's, because we know that they are 0 and 1. So 0 equals 1 plus 2 lots of D1. So D1 is equal to minus a half. But we know what D1 is in terms of P. D1 is just P1 minus P0. And now we've got D1, we've got P0. So we know that minus a half is equal to P1 minus 1. So P1, the probability of falling off the cliff after starting in that first place where our drunkard is, must be equal to a half. If you've enjoyed this video, don't forget to subscribe or check out more of my videos by clicking on the links here.